have 10 observations. What we already did, and I taught you, hey, let's compute the mean and the standard deviation to tell a story about these data, right? The mean is 178 centimeters. The standard deviation is around 12 centimeters. What does that mean? It means that on average, people tend to be, at least those people I've sampled, tend to be 178 centimeters on the average. However, I know that it does not mean that all of them are 178 centimeters. No, they come in different heights, right? And how different are they on average from the mean? Well, their difference on average from the mean is 12 centimeters. So probably within plus minus 25 centimeters, I have most of people. Plus minus 2 standard deviations. That's the story this tells about the population of heights that I'm talking about. Now, what we're going to do today, and maybe we already did in our minds when we looked at such data, but then we have done something that we should be a bit careful about at least think about. What we are going to do and emphasize even more today is that we are going to do this inferential thing where I'm going to take this number and consider it as the estimate of the unknown population mean heights out there, right? That's an unknown. I'd like to know that. I use my data, my sample to estimate it. At the same time, I'll also use, and that's why I call it sigma hat rather than S. Both names are okay, but now I emphasize I use it as an estimate of an unknown sigma out there. That is the average difference, the standard deviation in the population. So we're going to use it as that. Well, maybe we have said that and talked about that already. However, here are the two new things that I'm going to spend the whole 2 by 45 minutes today talking about. We are going to realize that these two estimates, and we'll spend most of the time on the first one, the average, are of course not the one and only truth, right? I think all of us will come with an intelligence brought with us through our whole life of brain development, that just because I see an average of 178 centimeters on those 10 guys that I sampled does of course not mean that I'm completely convinced that 178 centimeters is the true mean of all people out there. I know that, of course, that's not the truth. Otherwise, if you can't follow me there, you should get restarted your activity, right? None of us, I believe, would claim this to be the true mean because we know it's not. But how should we deal with that in practice? That's what I'm going to teach you. And here it comes. That's basically the results of what's going on today. Two new things. They are called confidence intervals, and they are intervals. So I'm going to teach you both how to compute the interval and how to understand it. And I'm not going to prove it completely, everything, but I'm going to let you know that there are some results supporting what we do. This one, well, I gave you the formula because it's quite easy, the formula. So that's, and we know most of the contents of this formula. Look at how should I make the confidence interval. I take the mean plus minus something. So I put an interval, right? Plus minus something. I put something here, which is basically just the standard deviation estimate divided by root n. And then I multiply by something, approximately 2, right? It's not 2, it's 2.26. I'll let you know why it's 2.26 and not 2 by the end of this double lecture. So basically, we take in plus minus something. This is the probability theory. This comes from a probability distribution. This is where we link the probability insights with our looking at the data to produce a meaningful interval, right? That's why I had to teach you a bit of probability, because we need some probability to make such a statement. This is something used everywhere. Wherever you see a report, scientific or business-wise, or if you're interested in the uncertainty about what you do, and you should be, and most people realize that it's a good idea to be that, then this is the tool for you. I'm also going to use the same idea. Not a nice box. I'm going to use the same idea on the confidence, on the sigma. But we'll get back to that. I don't show you the formula because you're not quite ready to see that yet. But in 90 minutes you will be. So let's get started with that. So that was the introduction.